Here is an application of derivatives. Kind of get us started. Good to get into. We're going to see a lot of applications of derivatives in this course, or a healthy amount. So, hey, this is our first one. And it's sort of like what you see in the project. It says a rock is thrown upwards on Mars with height h of t equals negative 1.86 t squared plus 9.3 t, where h is in meters and t in seconds. Okay, so obviously Mars has a weaker gravity than Earth, so you can really throw something high. A rock, you find a Mars rock and throw it upwards. That'd be fun. Okay, um, what's the question? Part A, at what time will the rock strike the surface of Mars? So here there's actually no calculus derivatives just yet. This is really an algebra question. At what time will the rock hit the surface? So if you thought of throwing that rock at time 0, so it's going to go up, make that parabola come down and strike the surface. And you can see my setup here. What's the height of the rock? The key to this is, what is the height of the rock when it hits the ground? Well, 0, right? So we're going to put 0 in for the height and try and figure out the time. At what time will the height be 0? Well, 0 equals negative 1.86 t squared plus 9.3 t. We're going to factor. And it's not obvious right away, but it turns out you can factor negative 1.86 t. So the t is obvious, but even when you factor out that number, dividing it with 9.3 will give you just 5. And if we take the negative, of course, then it's going to be t minus 5. Okay. So we can see there's two solutions. From here, t equals 0, and from this one, t equals 5. The 0, of course, is when it was launched. So maybe that's pretty low to the ground. So maybe that was, a Mars rover threw it up in the air and it was really close. And it flew through the air, and 5 seconds later, it hit the ground. That's a pretty good flight time, 5 seconds. That's a long time in the air. Okay. So that answers part A. Part B. Here comes the calculus. Find the instantaneous velocity as the rock strikes the surface. How fast is that rock moving at the instant it makes impact with the ground? Be a good question to know. Obviously, the higher up it goes, the faster it is when it hits the ground. So what do we need to do here to find the instantaneous velocity? We need to find the derivative of our function h at the time that it hits the ground, right? Okay, instantaneous velocity at that moment. So if you remember, kind of took it off the screen, but there's h of t. When we go to find this derivative, feel free to use either formula you like that we learned in this section. That's even going to be true on quizzes and tests. So I'm not going to specify which of those two formulas you need. You're always free to use either one. Although it's good to have practice with both. There's definitely an advantage to that. So maybe even in the homework, you're free to use whichever formula you like in the homework as you're working those out in 2.7. I would recommend, sometimes use one, other times use the other. Maybe do both for the same problem just to, practice for yourself. Okay. For this question, I'm going to use that first formula because I think most of the time that first formula we learned is easier. And I kind of like it conceptually. We can see the formula for the slope right there in it. So here's what I'm going to do using that first style for the derivative. H prime of 5 is equal to the limit, and of course our variable here is t, so the limit as t approaches 5, h of t minus h of 5 over t minus 5. And what I'm going to do is plug in our function here that we saw up above for h of t. I'm going to plug in h of 5, and it's going to be this. So h prime 5 equals the limit as t approaches 5. Our function was negative 1.86 t squared plus 9.3 t. And h of 5, of course, was 0 because that's the time when it hits the ground. Okay, so I'm going to ignore that 0, right? Because that would disappear. So from what's left, we need to factor to cancel out a t minus 5. And even fortunately for us, the way this problem worked in part A, we already know how this factors. Let me pull this up a little bit higher. We can factor out the negative 1.86t, leaving the t minus 5. Okay. And of course, these will cancel. So we can just plug the 5 in right there. Negative 1.86 times 5 gives us our answer. And it turns out it's negative 9.3 is the instantaneous velocity as that rock strikes the surface of Mars. If you were thinking, hey, what are the units on that instantaneous velocity? Well, if you think back here, the height is in meters, the time is in seconds, so that's meters divided by seconds, and those are the same units here for our derivative, meters per second. That's moving pretty fast, 9.3 meters per second. It's negative, of course, because it's falling. That is our answer. And that does it for 2.7. Check out the short video on the Desmos examples. That's it. Hey, that's our first week of sections. There's new homework up for 2.6 and 2.7. That's not due on Monday. That'll be due the following Monday. And as always, bring your questions to office hours next Monday. See you then, and good luck.